Hi everyone, welcome to another video. I would like to introduce you all today to Jood Al Aswad, a PhD student currently at Stanford. So I've invited her today to talk a bit about her experience obtaining a PhD in geological sciences and also being a student at Stanford. Thank you so much for joining me today.
Thank you very much.
Could you please introduce yourself a little more?
Yeah, sure. Hi, I'm Jude. I am originally from Saudi Arabia, and I have a background in geological sciences. So I did my undergraduate at George Mason University studying geophysics, and then I moved on to Cornell University, where I studied the physical layers of the subsurface beneath Cornell University for geothermal. And then after my master's at Cornell, I am currently working on studying the organismal recovery from mass extinction events, known as paleobiology, at Stanford University.
Wow, that's so interesting. Is there anything that you're researching specifically at the moment that you could share with us?
Yeah. So my most recently completed research project is based on a particular event called the end Permian mass extinction, which is the most cataclysmic event to have occurred to animals. It's also known as the Great Dying. About 79% of marine genera have gone extinct as a result of the end Permian mass extinction. And people have noticed that the ecosystems in the earth directly after this extinction event, they all seem to have a lot of the same animals living in them, regardless of whether those ecosystems are in the tropics or the poles or how far apart they are. And that's pretty unique and very interesting. And it's been really well documented, but we weren't able to understand why. And so my paper actually provides quantitative evidence that links the organism's physiology, so their ability to tolerate changes in temperature and oxygen, to them being able to spread out across all of these ecosystems around the world. So since this period of time is known as being very much more uniformly hot and less oxic, animals that thrive in such a condition are able to just spread out in the oceans.
That's really interesting. So you study a lot of your study has to relate with evolution. Why do you think it's so important for us to understand evolution as well as mass extinctions throughout history?
Yeah. So in particular, I focus on recovery from extinction events. And this is really useful, particularly to see how animals can recover from extreme heat, for example. So a lot of studies that people do try to relate mass extinction events to what's going on right now in the world, because we don't really have a recent precedent to the heat that animals are and will undergo in the future. And so we use these events in the past to help us understand how we can both keep these animals from going extinct in the future, and also to see the risk of extinction for these animals if we continue as we are right now.
I see. So it's not only just studying the past to understand it better, but also to understand how the future will work out.
Yes.
Okay. Let's talk a bit about your actual day-to-day life as a PhD student. So what is being a PhD student involved in terms of your work or in terms of like the amount of research you have to submit?
Okay, so there are two stages of PhD. There is PhD student and PhD candidate. In the student phase, there is a lot of classes that you take. So you are still a student, you're still learning a lot, and you're also developing the questions that you need to ask in order to continue on for your candidacy, at least for the US. In the UK, it's a bit different because the questions are already there for you to answer. And so it's a 3-year program, while in the US, it's about 5 to 7 years, depending on the program and the school. And so the first 2 years are learning all about the subject that you are specializing in, and then developing the questions that you want to ask, and then building up the research for that. You then go through something called a candidacy exam, which is where at Stanford's candidacy exam, it's like we provide a proposal to our committee, which provides all of the questions that we want to answer. So it's 3 questions typically, sometimes 4, as well as all the data for it and all of the preliminary results. And then the committee will ask us questions to see how ready we are for that and how much we will need to prepare for the next stage. And once you pass the candidacy exam, you're a PhD candidate. And so that's where I am right now. And so instead of taking classes, I am more and more commonly teaching classes. And it's not really much of a divide. I've taught before and I am teaching now, but it's more focused on teaching rather than taking classes. And so at this point of time, I divide my time between being a teaching assistant, which is what the teaching is, and then conducting my own research. And I've also been doing a lot of outreach, particularly in diversity. So I'm part of the Diversity, Equity, and Inclusion Committee of the Paleontological Society, and I was a student representative up until October. So I would say those 3 were the most time-consuming parts of being a grad student. But there's so much that you do as a grad student, and I think you really need to learn how to manage your time as a result of that. So there's answering emails, and there are lots of meetings as well. And you don't really have a structured schedule. You make that schedule yourself as well. I prefer to have the structure, so I like the 8 to 5, 9 to 6 sort of schedule rather than picking my own times. But say I was sick on Wednesday, I could just make up for that on Sunday instead. So that's one of the benefits of the PhD life.
Mm-hmm. And I'm wondering, how did your like transition to candidacy go? Was that a difficult process for you, or did you think you had a rather easy path?
Mm. The process of going through candidacy is different, not just in the discipline that you're in, but also the university or the department. So for my own personal experience, I freaked out a lot beforehand. I was very scared, because it's the type of exam where if you fail it, you fail out of the program. And I was very nervous about that. My professors, comforted me by saying, we wouldn't let you take that unless we were fairly certain that you were ready for it. But I still worried a lot. And the exam itself was actually very harmless. It was very nice. It was conversational, actually. So I had the proposal, they had read the proposal, and then I presented basically everything that was within that proposal and then some for about an hour or so. And then we spent the next hour or 2 hours talking about the research and about the minutiae of the data that we saw. So, hey, why is that data over there? Or why does that mean that? And how do you expect to learn about this? And what kind of classes are you planning on taking? But my committee has been very friendly, and they were not so intimidating. So they asked very tough questions, but it was fun, actually. The candidacy exam is pretty much the only time in your PhD where you're going to have basically a captive audience for a couple of hours that are only interested in learning about what you're doing. And so it's really great in that sense.
That's wonderful to hear, and I'm glad you passed without a hitch. Actually, I heard you were a student representative at the what was it again, the organization?
It's called the Paleontological Society. It's an international organization for anyone who's interested in or affiliated with or works on any branch of paleontology.
I see. So actually that leads into my other question. You seem to be quite involved in building community and as well as getting involved in the community. So how has your experience been like as a student representative or even as teaching classes in this subject?
Yeah. So student representative, that is a 3-year tenure. It's quite long, which actually is beneficial because it means that I had a lot of time to learn about the ins and outs of the society itself. The student representative represents all of the students to the council. So they have, we have the president, we have vice president, treasurer, and etc. And the purpose of my position is to bring forward any concerns or any interests that the graduate, undergraduate, or other students might have to the council, and to provide a safe space for students as well. So because I was concurrently a student representative and DEI, or Diversity, Equity, and Inclusions Committee member, I was able to do something really cool. I created an award called the Diversity, Engagement, and Enhancement in Paleontology Award. And it's an award that the Paleontological Society presents to students and early career researchers for any initiatives that they've done to make paleontology a more welcoming space. And that was a lot of fun, actually. So I would say there's that, but we're also able to create events and connections for students so that they would have mentors, for example, that they'd be able to talk to, resources, as well as financial resources for attending conferences or travel and such. So yeah, that was a lot of fun, actually. Teaching wise, let's see. I think that teaching is the most fun that I've ever had experience doing before. So I've taught a week or a module of classes at a community college. And I've taught a module of a mixed undergrad graduate student class as well. And then I've taught a couple of lectures at Stanford University. And so it's like this sliding scale of different audiences that I managed to have experience teaching. And I think that I loved all of them. And it's a lot of fun, but it's also quite a lot to learn about. So I feel like when it comes to teaching, the most important thing to know is that each time you teach is going to be different, even if the audience is the same. And so, if I taught a class one quarter, I should not expect that it's going to be exactly the same the next quarter. And because it's so dynamic that way, because the students engage differently, or because the material itself is going to be different, it's really fun sort of adapting to that change.
Mm-hmm. So would you say the reason you enjoy teaching so much is because it's kind of like a challenge every time you teach a class?
Yeah, definitely. I think the most fun part, though, is the students themselves, their interest in learning, or just sort of the questions that they ask and how different what each student is from one another. I really love getting to know them.
That sounds really fun. I'm so glad. So earlier you touched a little bit about the importance of community as well as diversity. So why do you personally believe in the importance of building a community within science or within the Paleontology Society?
Yeah. So I guess it started when I majored in geology, actually. I was looking around the class and I thought, oh gosh, I'm the only person with my skin color here. And that was the first time that's ever happened to me. And unfortunately, with geological sciences in particular, our field is not very diverse. It's the least diverse in STEM. And in paleontology, it's even worse. And I think I might be the first female Saudi paleontologist. I'm not entirely sure. And so I feel like I don't really have someone that I can look up to, or like a role model to look up to, or even like a colleague who's going through the same things as me. So I wanted to make that for other people. So I wanted to build that sense of community and belonging for people who also felt like, hey, I'm kind of different, or maybe I look different, or, I have a different background from others, because I think that having a diversity in backgrounds and perspectives actually really enriches sciences. And I want those people to feel like they belong, even though historically our sciences were represented by a very specific demographic.
Wow, I love that initiative for you. I think it's great that it's coming from a place where you want to help others to not to go through things that you went through. Um, let's talk a bit about how you got into paleontology. I'm just wondering, did it start from like a young age, or did it gradually like lean this way and you just went along with it?
Yeah, just like many other paleontologists would say, I definitely started when I was young. I think when I was about uh, 5 or 6. It was the very first career I was interested in. I was like, I'm going to be a paleontologist. I was one of those smart alecks that whenever you would play hangman, you had those words. I would spell out paleontology because I knew how to spell it and I was showing off. And then I went to Jurassic World in Disney. I think it was, gosh, where was it? Universal Studios. And that particular activity requires digging through and finding bones, but actually all of the students had already found, not students, children had already found all of the bones. And so I spent about 4 hours digging, looking for them. And I was maybe 6 or 7 during that time. And I was very frustrated. And I told my parents, this sucks. Why is it taking so long? And they said, this is paleontology. And as a child, I was like, this will not stand. So I switched over to marine biology and I kept switching around from science to science as I grew up. I knew I loved science. I just didn't know what kind. So um, I actually hadn't gotten back to paleontology as an interest until I was an adult and when I rediscovered it. So I was enamored with geology. I just love it because it's like, oh, you're learning about the earth, you're learning about how mountains form, you're learning about how oceans basins form. It's so cool. You get to look at a rock and be like, oh, this rock came from that mountain, this many years ago. And there's so many different branches of the geosciences you can get into. So when I was doing my master's, I had a lot of fun with it because I I was thinking, oh, Saudi Arabia has a lot of potential in geothermal. And so maybe I can sort of bring this knowledge back to Saudi Arabia and we can have it as another source of energy, a renewable source of energy that we can tap into. But then when I was reading what we call literature review, so it's sort of papers that we look at as we prepare for our own research, there was commonly this phrase, coevolution of life on Earth. And I was just like, oh, this is a cool phrase. And I started looking into it. And then I did my own side research and I was like, oh, okay. So there's an entire field that looks at how life had changed as a result of changes in Earth and vice versa. And it's called paleobiology. So I started doing those readings for fun. And as soon as I saw my now advisor's own papers, I was like, I want to do this for the rest of my life. So I contacted Dr. John Payne and I said, hey, I'm a current graduate student. I'm not studying paleontology right now, but I'm very interested in it. Would you perhaps be willing to take me in as a PhD student? And luckily, he eventually, after a bunch of interviews, was like, yes. And ever since then, I never looked back. It's so much fun. I really, really love paleobiology.
Yeah, I can clearly hear the passion in your voice, and I think it's great for you that you found the one thing you can hold on to throughout your life.
Thank you.
So that actually kind of leads us to my last question for the day. My last question is, if you had to give one piece of advice to a high school student, what would it be?
To high school students. I suppose it's twofold. The first is that it's never too soon to get started in something that you're interested in. There are many opportunities for high schoolers to engage in whatever topic they're interested in studying. So if it's paleontology, for example, there are many initiatives that you can also probably check with the Paleontological Society that would help high schoolers learn more about paleontology or engage in them, maybe even do research regarding them or internships. And then the other is that you don't feel pressured to know everything that you want to do in the future right now, because it can change. My own career is sort of a reflection of that. When I was a high schooler, I actually had applied to universities thinking I would major in biology, and that was originally my major. And I realized very quickly that I didn't want to do just pure biology. I wanted geology, and I had switched over. And careers are honestly very rarely linear, where it's like you start with a career path that you want, and then you stick with it for the rest of your life. Sometimes you meander around, so it's okay if you do.
Okay, that's great to hear, and that leads us to the end of this interview. So again, thank you to Jude. Thank you so much for coming and talking with me today. I hope everyone who watched this enjoyed this episode, and I'll see you all next time.
Thank you.